good afternoon, good morning, good afternoon, good evening to wherever you are. A warm welcome to all the participants. Just a quick introduction about myself. I'm Samir. I'm an enterprise architect within the digital group of Atos. I'm based out of Mumbai. I actually primarily lead the solutioning for large deals for my practice. I'm also a distinguished expert in the modern applications domain. I provide architecture and technology leadership for different opportunities for Fortune 100 customers. So welcome to this session. I'll start sharing the presentation. Today I would like to let's say walk you through a session named Beyond Monitoring: The Rise of Observability. This is one of the trending sessions, and I've had opportunity to basically share this with a lot of let's say opportunities, and also on various forums as well. So I think let's go to the content, the table of content. So what I would want to cover or let's say walk you through is the observability background. What is exactly the observability? What are the goals? What are the objectives? Then a kind of a sort of view on what observability is in terms of the tooling, the methodologies, the processes. Then there's a comparison.
Sorry, Samir, I don't want to interrupt you, but we can't see the presentation yet.
Oh, okay. Just a minute. I think I have already. Have I not shared it?
No, not yet.
This says this will stop.
Yeah, that's totally fine. You can just take over the screen. That's how it works. Yeah.
Yeah. So then I think that should be the issue on it. Just let me know if you're able to see it now.
Yes, we can see it now.
All right. Perfect. So.
All right. Great. Thanks.
Right. Yeah. So this is the table of content. We start with the background of observability. Then we provide a view on what exactly does it contain. There's a comparison between monitoring and observability as well, because monitoring are the earlier generation, let's say, toolings that were leveraged to basically provide a similar set of features, similar set of capabilities to the enterprises. Then the pillars of observability and what is Open Telemetry Framework. It's a standard by CNCF, which is basically followed while you're actually, let's say, building and deploying observability solutions. Then a walkthrough of what observability framework is, what exactly it constitutes. So if you're building a solution on observability or for observability, what exactly it constitutes. So observability is not just a kind of a, let's say, tooling or a solution from, let's say, one specific vendors, but there are multiple vendors and ISVs which are providing that. So this basically is more of a framework to tell you what exactly constitutes that particular solution, that framework. Then the KPIs and the KRIs that are impacted by observability. We also have let's say some details around the tooling stack and the monitoring platforms of the current generation, let's say, enterprise systems. And then the AIOps part, right? AIOps, because that's something that is interlinked. So all these various elements, right? We have AIOps, we have site reliability engineering, observability, monitoring. All these are actually interlinked. Some of the terms are basically coming into us from the legacy solutions, legacy system that we have. But observability and AIOps are the next generation solutions that you would see in as part of Fortune 100 customers. So let's move on to the next slide. So this is basically, and why would we need anything like an observability, right, or a monitoring? See, if you see the overall context of these, let's say, systems that we have, or the entire, let's say, landscape of applications that we have in let's say in the enterprise systems. For Fortune 100 customers, they have a kind of a huge list of those solutions, right? It might not be limited to just one or two solutions, but it will have, let's say, your HRs, your finances, your marketing, your ERP, CRM, your middleware, right, portals, so on and so forth. And those systems are fairly complex. So if you have a small system where you just have a single app or just a portal, I think that might not have a lot of complexity, and you would still be able to do away with the observability part. But for the enterprise applications or the enterprise applications for Fortune 100 customers, I think these overall application landscapes are fairly complex. Right. Also, if you have a situation or a scenario where you have your systems are down, right, or they are not performing up to mark, you actually are going to impact the customer experience, which would be causing a revenue loss for your organization. Also, it said that anything, let's say about 3 seconds or 2 to 3 seconds, right, that's going to, let's say if you are actually, let's say if you're on a site, on a website, and you are actually trying to, let's say, read something, or let's say you want to view something on the site, anything beyond 2 to 3 seconds is basically going to impact the customer pretty badly. So I'm sure the customers would want to run away from your sites. For this not to happen, you definitely need all these solutions to tell you and how those are, let's say, monitored, and how you do the root cause and do the course correction, right? So this is basically what the background is. So observability provides you a kind of a complete cutting edge stack to find, let's say, a needle in your haystack, considering that the application landscapes are complex. It's not limited to a handful of applications, but there would be hundreds and hundreds of applications. I think observability provides you with the entire tooling stack to basically do that, to monitor your complex landscape. Also, it actually is a solution that is leveraged by not just a set of, let's say, teams, right, but it has various, let's say, stakeholders who would also be leveraging these solutions. We have the DevOps team who would actually leverage it, right? We'll have the site reliability engineering, which will actually leverage it as well. We'll also have elements of, let's say, if you have a modern data platform, you'll have all your data pipelines implemented. We'll have your, let's say, the data team also basically leveraging these solutions. So if you see, it's a solution that is a kind of a critical solution, which basically provides you with a lot of insights and intelligence to, let's say, drive your applications and systems to make sure that the uptime and availability is maintained as per the SLAs. So I go on to the next slide, and as I said, the complexity is basically something that cannot be managed by manual, let's say, solutions or manual processes. It has to have an automation, and observability provides you with those automations to make sure that if you are actually having, let's say, scenarios where you are unable to, let's say, find details from your web logs, from your application logs, let's say, from your matrices, and believe me, it's like you'll have megabytes, gigabytes, terabytes of data if you are actually running your applications. If you have business critical systems, you'll have these logs and matrices and traces getting generated, but you can't actually manually go through it. You'll have to have solutions. You'll have to have that intelligence. You'll have to have that machine learning algorithms to go through it and get you the insights, right? So this is basically where observability plays a key role. You can call observability as a next generation APM, because I think that's what it does, right? The APMs that were there in the earlier, let's say, earlier times, they basically were limited to only static, let's say, informations, static reports and dashboards. I was always intrigued by the fact that when I saw the teams basically looking on various, let's say, on a huge, let's say, display where there were multiple, let's say, monitors running, providing details about various parameters and various features of the application. I think it was just amazing to see that. So I think APM has that, let's say, was the first generation or the earlier generation solutions, and observability is what we have as part of the current solution, which is also a kind of a cutting edge solution that we have. So I think it makes sure that observability provides you with that, let's say, capability through which you can instrument your application. You can gather insights, explore patterns, and actually make sure that if there is a course correction that needs to be done, it provides you with predictive analytics, right? So it tells you even before, if there's a kind of a, let's say, a system crash that is going to happen, that's going to be happening, or if there's going to be, let's say, performance bottlenecks that will happen eventually, it actually alerts you. It actually provides you with that intelligence to tell you all right, this is what I need to do. This is where I need to, let's say, resolve, or this is where I need to deploy the right set of changes, so to make sure that the high availability and resilience of the systems are maintained as per the SLAs. So next slide actually mentions about or depicts about the observability and monitoring. And as I've been saying, it's the generation of systems. So one is earlier generation, observability is the next generation, or the cutting edge systems we have for Fortune 100 customers. There's one of the very interesting insights that we have by Gartner. It says 30% of the enterprises implementing distributed system architecture will adopt observability techniques to improve their digital business performance, which would be up for 10%. So this basically, as you can see, more and more enterprises are looking at building these more and more complex, more and more distributed enterprises are looking at building this capability or deploying this solution, right? So that's the key difference between the two solutions, or the two different generation of systems that we have. The next slide, it talks about the pillars of observability, right? They also call it as a telemetry data. And this is basically something that is coming in from the CNCF, right? Cloud Native Foundation. They have come up with a standard for observability platforms. So this is a standard that more or less each of those vendors that are there, be it your Azure, be it your AWS, be it the open source solutions, or your ISVs, right? They would need to basically adopt these standards, because that's probably what they have done. Earlier generation systems didn't have. I think this is basically something that is recently launched. But this standard is something that tells you these are the things, these are the data types that you want to basically manage, monitor, and analyze to get you the right insights from your solutioning stack. So what are these things? So there are three things here. So there is one is a matrices, which is nothing but a numerical value of some parameter measured over an interval of time. And it can be a CPU, it can be a memory, it can be a processes count, it can be a thread counts, and all those things, right? So those are the matrices that are monitored. Logs are something that are basically timestamp records of events that occur, right? So this is basically nothing but if you are actually, let's say, if you know about let's say call stack, right, which basically gives you a complete, let's say, hierarchy of various events that have gone on. Let's say if you're making a function call, and that function call makes another function call, and that makes another database system call, and the database system makes another API call for an operating system, and so on and so forth. So an entire log trace of that is what is basically captured by this particular telemetry data, which is called as a logs. And then comes the traces, and traces are very interesting. And I think to explain to you what traces are, right, if you are actually, if there's a user which is let's say on the portal, let's say viewing a products, and eventually he'll buy the products and place an order, right, that entire journey of user request, actually it goes through various solution building blocks. Let's say starting from your portal to your integration systems, then your, let's say, your product system, which basically will be your CRM, and then you place an order there, and then from that order it goes to your billing system, and from your billing system it goes to your logistics, and so on and so forth. So all these things, if you see, they have interconnected applications, making sure that the integration layer, making sure that all these applications are basically talking to each other with, let's say, open standards and protocols, using your REST-based APIs, or your SOAP-based APIs. But these are, again, they're cutting process, they are cutting across process boundaries, right? So these are the ones which are also critical while you're building the entire, let's say, user experience or end-to-end journey of the customers. And traces are those elements that make sure that you are gathering the information or insights around the distributed architecture, so that each interfaces, each integrations that are there in your architecture are also traced as part of your entire journey. So that's where the traces are. So these are the three elements that are typically you would leverage to gather, to manage, to let's say synthesize when you're deriving your insights for your observability stack. So these are the key elements, right? Then there are these KRAs and KPIs that observability impacts. So you have user experience, as we have been seeing, right? It is something that would drastically improve if you have the intelligence, if you have the predictive capability. It will give you advanced warning in terms of what issues, what problems are coming in. Next comes the mean time to repair, right? It reduces the mean time to repair, because I'm sure with the insights that you got, with the intelligence that you get, anomaly detection, root cause analysis, all these will actually make sure to get a quicker resolution to it. So mean time to repair is something that will be improved significantly. So is mean time between failures, because I think if you have a system to actually alert you of those eventualities, you make sure that you will improve the mean time to failures. You also have reliability and availability. Obviously, these are all interlinked if you see, and then they say this definitely provides higher reliability and availability of the systems. Same is the case with performance and scalability. So if you have those things integrated into your observability stack, you will make sure that you are monitoring it and taking corrective actions when you see there's an issue happening, if there's a bottleneck that's there, and how that is resolved. So this is basically those entire set of KRAs and KPIs that are impacted. Obviously, they are only improved if you have the observability solution stack in your as part of your enterprise landscape. Then comes the observability platform objectives. What does it constitutes? What is it that observability provides when you are actually, let's say, deploying a solution like this? So it does, what it does is it gives you an enhanced visibility of your system performance and health, right? Then it discovers and addresses unknown issues and accurate insights, right? So this is basically what constitutes the root cause analysis, right? Then it with these it may also make sure that you have fewer problems and blackouts as a result of observability capabilities. Rightly so, if you have that intelligence, you will take the right decisions, you'll get the right insights, you'll take the right decisions to maintain the required availability and uptime, right? Then predict issues, which is again a key let's say capability of these solutions, which will predict issues even before they are observing, even before they are happening. And that's what are the if you have heard of solutions like AIOps, right? These are basically what those solutions are. They basically will give you the predictive capability to analyze situation and flag any issues that will happen in future as well. Catch and resolve issues, again, it's also interlinked. And then you have deep dive logs and stack traces, which is basically, again, one of the key properties that these solutions also have. And what is a framework, right? What exactly are the, let's say, best practices and guidelines for the capabilities to build this kind of a solution? So as we saw, the framework is something that we saw it in the earlier slide, is basically something which is actually also kind of a part of the overall journey of the solution, overall story of the observability solution. And what it does is it reports on the overall health of the system, which includes uptime and availability. Then you have the tools to help understand and debug systems in production, making sure that you meet the service level objectives and SLAs for your systems, which actually is done via event correlation, which is basically a capability or a service that, or a feature that this solution provides. Access to tools and data that help trace, diagnose infrastructure problems in production and do the root cause analysis. So what's important here is to basically know that while it does the event correlation, that event correlation results into your root cause analysis as well. While it runs through and investigates your various logs, various matrices, various traces, it basically provides you with why it happened, where it happened, how it happened, and probably what is it that you need to do to correct it. Then we have the tooling to have the identify unanticipated problem, which is basically the predictive capability that we have. So making sure that which in observability circles is also known as unknown unknowns, right? So that is called as the anomaly detection as well. So making sure that in case there's an issue that is going to happen, let's say in terms of performance, in terms of your scalability, in terms of reliability, in terms of your, let's say, availability, uptime, all those things will basically, because you have the intelligence of the solution, right, you'll actually be able to identify them and resolve them even before they happen. So that's some of the key things that you would get as part of your solution stack. Now comes the, let's say, core of this particular presentation, right? So this is basically the the reference architecture for observability solution. So on the left side, if you see, that's the distributed application that you have. And from that distributed application, you have shippers, or they are also called as probes, which actually get that data from those endpoints, right? That those endpoints can be anything. It can be your edge device, it can be your content delivery network, it can be your IoT hubs, it can be your web servers, application servers, databases, load balancers, you name it, right? If you see a cloud native application, these are the things that you would typically see. You will have your various other networking elements as well, not just your application stack, but also your network and storages and all elements around that. Those entire set of things can be monitored. The data pipelines, right? Data pipelines are also something that are monitored by observability stack. Same is a case with, let's say, if you have a machine learning solution, I'm sure machine learning is also having its own SLAs, right? You typically, what you do, you build the model, you train it, you deploy it, you monitor it, right? So this is basically something that can also be integrated into some of these solutions. So that's basically what shipping and the probes are for, or shippers or the probes are for. Next is basically the data ingestion. So if you see the first vertical block there, that is your data. And what is it ingesting? It's ingesting the logging data. It's ingesting the tracing data. It's ingesting the matrices or the matrix data as well. The same that we saw earlier, right? We have the telemetry framework, right? That we showed. This is basically the same elements or the same parameters that it's ingesting into this particular stage of the pipeline. So that's basically captured at this stage. The next stage is where you do the aggregation and processing. So look, this is basically having those capabilities of pattern discovery, anomaly detection, root cause analysis, event correlations, right? So for you to do that, that's the next stage of the pipeline. So for you to do that, you have to get the data in the right, let's say, format, in the right semantics, making sure you cleanse the data. So I think typically if you see the data aggregation and processing, let's say, data pattern, you'll typically have 3 stages of it. The first stage is where you just ingest your raw data, which is coming in from the earlier stage, right? The second stage is where you, let's say, cleanse your data, making sure just getting it to the right semantics and the quality level that you want. And the third stage of this particular let's say data pipeline is making sure that you aggregate the data, which is basically then leverage to get the insight. So this is basically what the pattern is in terms of this platform. So that's the second stage, which is data aggregation and processing. The next stage is basically where you have the analysis and machine learning as well. So while you have the data in the right, let's say, format, right semantics, these are basically all the analysis that you do on top of it. You do the pattern discovery, you do the anomaly detection, you do the root cause analysis, event correlation. So there are multiple things that would go in as part of your, let's say, intelligence that you have. So this is a very critical, let's say, solution of that pipeline, or a capability or service of that pipeline. This is basically what gives you that ability to, let's say, do a predictive analytics or an anomaly detection or a pattern discovery or a root cause analysis. And believe me, I think if you see the amount of data that is getting generated, it just runs into petabytes and exabytes, right? Which is basically cannot be handled without these systems or solutions in place. So that's where these particular solutions or features are required as part of the observability stack. And then on the next, or rather the next stage of the pipeline, we have the dashboards, we have the alerts, right? We have the notifications, and we have the auto remediation as well. I'll just explain to you. I think this is basically what we call it also as a self-healing infrastructure, which includes a kind of a closed loop system, right? Where you will once you gather the insights, right, from the earlier stage about what is the root cause of something, some issue that is there in your enterprise applications, enterprise systems, this is basically what the final stage does, right? It does produce the reports and dashboards, so that all your let's say the command center, as they say it, right, in this particular terminology, the SRE, site reliability engineering, or the command center, they have a view on the various endpoints, various nodes that's there in your application, and then they get the dashboards and reports of the entire application landscape. Then they provide the alerts and notifications, right? So the alert goes to service desk as well, saying, look, we are basically having a problem with, let's say, some virtual machine in the distributed architecture, and that needs immediate attention. So that's one part of it, right? It actually alerts the service desk. The second part, it also is integrated with ServiceNow. So this is basically going to raise a ticket for you, saying, look, I think we have an issue with the system. There seem to be some issue with a virtual machine on your hypervisor and or your hyperscaler, and that is something that needs to be corrected. So with these in place, you can see it just ingests the right elements of data into the ServiceNow and then notifies the service desk. This basically then and as you see, there's also an auto remediation built into it, which means it's going to trigger your automated processes to make sure that for the identified virtual machine, which basically is having an issue, it makes sure that that machine is restored to its normal form. So it might need, let's say, redeploying something, it might need restarting it, it might probably need changes to the configuration. But this is what let's say self-healing infrastructure looks like. So what I've done and what I've tried explaining is a very, let's say, fundamental use case, but I think you can extrapolate it to having more complex, more involved use cases, which can actually make sure to make the resolution. Again, it's something that will also go through a lot of process to let's say optimize and make sure that it is tuned to the requirements of your business, to tune to the requirements of your landscape. But I think this is basically what a hyper automation looks like. So we have that entire thing built into the solution, which will make sure that it provides you with the right let's say capabilities to do an auto correction. So this is basically the reference architecture. Just a view on some of the products and tooling. So while I've worked on a good number of them in the past, a lot of these solutions have very similar capabilities, right? So there are toolings from Azure, we have toolings from AWS, there's a tooling from open source as well with various libraries and various frameworks. And we have the ISV products as well, right? App Dynamics and the New Relics and the Dyna traces, right? So we have various solutions, various products. Each products have its own, let's say, pros and cons, or its strengths and weaknesses. We'll have to definitely do a kind of a comparative, let's say, study to, let's say, find the right fit for a certain customer requirement. But mostly, this is basically what you would look at when you are actually building an observability solution stack for your customer, right? So I'm now going to the next let's say slide, which basically nothing but the KRs and the KPIs. This only related to the matrices. So as you saw earlier, there are three different telemetry types, right? The observability pillars, as we said. So we had matrices, we had logs, we had traces, right? So this is basically related to only matrices. So if you see, this is basically these are the set of things that are predefined. So if you want to look at the KRAs and KPIs for, or rather the matrices, you'll have 17 KRAs and KPIs for app services, about 7 for cloud services, 7 for database systems, about 8 for end user experience. So these are all out of the box. You just need to deploy them onto your observability stack, and they can actually start, let's say, pumping in those details into your data pipeline to get you insights and intelligence, right? So this is basically the matrices. If I go to the next, let's say, slide, right? This is basically just the first. So when I said 17 different KPIs for that application services, these are what the 17 APIs look like. So you'll have the CPU utilization, you'll have memory utilization, thread count, process counts, you'll have active sessions, you'll have garbage collection times, you'll have memory heap sizes, etc. So these are all the parameters that get pushed into through your shippers and through your probes into your data pipeline, and then finally they'll land into your reports and dashboards. That's where you get I have a slide which basically also mentions about or shows what those dashboards look like. So so I think that just a scaled down version of that slide, scaled down version of that report, but just to give you a gist of what those dashboards look like. So this is basically that example. So there are predefined, let's say, out of box templates that you can leverage to get these matrices, logs, and traces. Again, based on each of your solutions which you're leveraging. Some solutions definitely have out of box features, because I think a lot of them do the heavy lifting for you already. So you don't have to basically reinvent. I'm sorry. You don't have to reinvent a wheel all the time, so you can leverage those templates in your solutions. So this is what I was telling you about. Again, this is just a scaled down version, is giving you a view on what application securities, infrastructure, and networks look like. As I said, right, it's not a kind of a just one screen that you see. If you have seen, if you've got an opportunity, there's a complete command center. You'll have at least a group of a big team of let's say experts monitoring your various nodes, various solutions, which actually has a huge wall on which you'll have different monitors mounted, and those experts will actually be monitoring all these key parameters, all these matrices, logs, and traces. This is something that is coming in from the Azure monitoring. Again, something that you can leverage if you are, let's say, building solutions on top of Azure. Which is basically a solution which is on similar lines of observability as we are discussing. And then we have the AIOps architecture, right? So I think up to now, what I've tried explaining is mostly the monitoring data, right? It's you have everything that is, let's say, gathered from your endpoints, from your nodes, from your clusters, your infra layer, your app layer, your UI layer, integrations. All those things are basically specifically around your monitoring, right? AIOps is, let's say, another, let's say, capability where you actually also get, or rather also integrate your transactional data details into your stack to get you the insights. Because I think at times it so happens, right, that just monitoring data is not sufficient. You need external data as well to, let's say, correlate, to do the root cause analysis, to do the anomaly detection. So AIOps is integrating that business data into your monitoring stack, be it your CRM data, be it your ERP data, be it your customer related data, logistics data, you name it, right? So this basically getting your business data as well to be ingested into your data pipeline, so that you, from that data, you then either do a real-time processing or you do a batch-based processing, right? On that. And on top of it, you then have the various elements of machine learning, pattern discovery, anomaly detection, statistical and probability analytics, etc. So this is basically making sure that you have a holistic, let's say, access to the entire stack of your data, on top of which you run the various algorithms, various solutions that you have. So this basically is what they call it in the or as we understand it, as AIOps solutions or AIOps architecture. So this is basically what provides you, or this diagram actually gives you that, let's say, details. I just want to also quickly mention about a solution, or rather a scenario where you leverage what exactly is the difference between leveraging observability and without observability, right? So so on the top line, on the top, the first row that you see, this is basically, let's say, a solution without the self-healing infrastructure in place, or hyper automation in place, if I have to explain you that way, right? So once a problem is detected, so this is basically showing a Dynatrace plus a ServiceNow plus an Ansible, right? So the earlier, let's say the first scenario, the one that is depicted on this particular, let's say, row, the first row, it is basically a scenario where you detect a problem. Then you do the auto ticketing, right? There may be auto ticketing, there may not be auto ticketing. So let's assume there is auto ticketing. So that problem detection goes into your ServiceNow, and from ServiceNow you have the level 2 support, which is doing a triage, right? It's trying to find out what exactly has happened, where it has happened, what's the domain, which part of it is it, infra, is it application, right? And then that L2 support, it triages it to L3 support, and L3 support is where there's a dev team sitting, and then they'll analyze it and they'll do the remediation. If you see this part, right, it's just an indicative number that is going to take 60 minutes of your time to basically, let's say, making sure that you fix it, you resolve it, right? So this is basically the overall solution without your automation, without making sure that you have the self-healing infrastructure in place. How observability solutions resolve this problem is what is explained in the next row. So the problem is detected, there's auto ticketing done, and then you analyze that entire solution, entire issue, do a root cause assessment, do an anomaly detection, and then do an automated remediation as well. If I have to go back to my earlier example, like let's say we have an issue with the virtual machine and it needs to be restarted. So this is where the auto remediation takes place. The Ansible is a solution where you have your infra as a code, so you can actually leverage Ansible to manage your entire infrastructure, entire cloud infrastructure, entire on-premise infrastructure. So if the virtual machine needs to be deployed and it needs to be restarted, Ansible is what will do it for you. So this is basically now two different scenarios that we are comparing, right? The first scenario we are saying it takes about 60 minutes, and the second scenario happens in 9 seconds. So if you see, we have taken a very simple example of a virtual machine restore, right? The scenario can get even more complex than that, but if you have these automations in place, you will see how much efficiencies and how much scales you can build as part of your solution. So this is what is this is what is provided as part of your let's say also observability solutioning. Finally, just wanted to cover about the infra as a code. I'm sure it's one of the very multi-purpose tool we have. I would say it's like a Swiss knife, right? It basically manages various elements of your infrastructure, be it your firewalls, load balancers, application containers, etc. And what can it do? It can do the configuration management. It can do a deployment. It can do a provisioning. It can do a continuous delivery. So this is basically like a Swiss knife. That entire, let's say, your entire infrastructure can be managed through ISC. It's like, even if you have a disaster recovery site, you can actually make sure the disaster recovery site is activated, leveraging the power of, let's say, infra as a code framework and tools that it encompasses. So that's what infra as a code is. So that covers the ISC part. And I think if you're building a self-healing infrastructure leveraging observability, this will become a significant component or a critical component as part of your solution. So this is just a view on that, which I just explained. And again, some capabilities you might not find. So the next slide, it basically mentions that there are some elements that you might not find in some of the hyperscalers. So you'll need to, let's say, combine it with capabilities from other ISP solutions as well. So that's where we are actually showing that for real-time auto discovery, you need some of the solutions to be integrated into Dynatrace. So is automatic discovery as well. So these are the ones that have to be collaborated. All these things have to be integrated, and you have to build a cohesive, let's say, solution to take advantage of AIOps, which is explained on this slide. And lastly, again, the kind of differentiators we have for our solution. So it's definitely user-friendly, which I'm sure when you are actually building it, it has the right UI UX so that you are able to intuitively leverage some of these solutions. And that's what the next generation solutions are for. That's what observability solutions are for. It gives a total visibility of your systems, of your landscape, so that you know exactly what is happening, where it's happening, and what is it that you need to do to resolve it. It drives business value. Of course, it drives business value. If you are making sure that you have the right uptime and availability, you are not impacting the customer experience. Definitely, there won't be any revenue losses. If your user experience is right, if your user experience is up to mark, I'm sure the customers won't run away from your site. So that's what you're actually doing as part of this particular solution. And then real-time actionable insights. Obviously, you are actually ingesting data in real time through your shippers and probes, so that you know exactly you get actionable insights in real time. So you don't have that batch mode to run wait for a few minutes, a few hours, and then understand what the issue is. You can actually do it on a real-time basis. While one thing I would definitely like to make a mention is there is a real-time aspect to it. There is a batch aspect to it as well. So I think those solutions typically have both these elements integrated so that you have the right, let's say, capabilities deployed to get insights from the various solutions, various capabilities, and support modern techniques. Of course, it does support modern techniques like CI/CD, DevOps, automation, and all those things. And it can be basically plugged into your CI/CD tooling as well. So these are the quick differentiators. And I think I've reached the end of the presentation. I've just mentioned my Twitter handle, my mail ID, and my LinkedIn link as well. In case you have any queries, feel free to reach out to me. And thanks a lot for patiently listening to me. I hope you have found this discussion insightful and thought-provoking.